welcome again to the Virtual Flow Forum for this year. All really about wastewater flow and flow to full treatment. It's such an important issue right now, as the water companies, to my estimation, are investing around about £1.5 billion on flow to full treatment, and those are involved. There's a lot of work going on. So as we had a bit of a interruption there, I'm going to go straight to Pete Baker from the Environment Agency, who's going to be our first speaker, talking about improving the regulation of flow management at wastewater treatment works. So Pete, do you want to take it away?
Yeah. Hello. Hi, everybody. Yeah. I'm Pete Baker. I work for the Environment Agency. I'm a senior advisor in water quality. I work in the head office, and I'm my focus is on permitting and compliance. And for the last several years, I've been focusing on flow and flow regulation. And this presentation is about the importance of flow regulation and how it's been improved, or how we do regulation of flow is being improved. So could I have the next slide, please? So flow compliance at sewage works. Why is it important? There can be unexplained failures of Water Framework Directive standards downstream of sewage works, and but the principal control of sewage works that we've had for 20 odd years is and more, but a real focus has been on discharge quality and discharge quality compliance of treated sewage effluent. And the compliance with discharge quality limits is good. It's at around or above 98% of sewage works are compliant with are not failing numeric discharge quality limits. But we know that flow is also important. So flow together with discharge quality, controls the load of pollutants, the load of what's discharged from a sewage works into the receiving water. So we have dry weather flow limits in permits, which along with discharge quality control the load and the impact of discharges. We also have flow to full treatment settings within permits, and those settings control the volume of sewage that must go forward, or the rate of flow of sewage that goes forward for full treatment, with surplus excess going over into storm tanks. So having these limits, having flow to full treatment compliance limits, it's there to avoid damaging discharges on dry days, and also to allow storm tanks, once they've filled, to be emptied as soon as reasonably practicable, ready for the next subsequent rainfall event, storm. So, yeah, thank you. So, well, just as a mark of how long we've been looking at flow to some extent, we have a Flow Task and Finish group, which was set up in 2017. It's got members from the agency, water companies, and National Resources Wales, chaired by Dom Shepherd, who we'll be hearing from tomorrow. So the key aims of this group has been to improve the regulation of dry weather flow and flow to full treatment compliance at sewage works. It's about also improving flow data quality, and also supporting the development of the PR19 AMP7 Flow Drivers Programme, which Oliver referred to a minute or so ago, and to support also the development of conditions that will be used to recognise the AMP7 flow driver outputs, which will need to be included in permits. So next slide, please. So I'll just quickly talk about dry weather flow before moving on to flow to full treatment. So dry weather flow is basically it's the flow that's received. It's been defined. The definition changed over 10 years ago. So it's basically the flow that's exceeded 80% of the time, and we assess compliance with it using the flow that's exceeded 90% of the time. So it's an annual assessment. We use the total daily volumes that have been measured by driver the flow monitors that are MCERT certified, and if the Q90 of a year's total daily volumes is bigger than the driver the flow limit, then we say that it's exceeded its limit. But whether or not it's failed with the existing condition is subjective, because we also then have to assess whether or not the operator's taking appropriate steps, or if it's due to unusual rainfall. And so you can end up with having exceedances that might go on for a while whilst the company or the operator's carrying out appropriate steps. And it's not a clear, it's not a clear defined pass-fail condition. So next slide, please. So from 2026, we're keeping that same assessment approach the same. The monitoring will remain the same. The assessment in terms of whether or not there's been an exceedance of the driver of the flow any year will be the same. But the difference is that if within a 5-year period you have on your third exceedance, then the driver of the flow limit has been failed. So it's a clear compliance test. There's no ambiguity. So it's the intention is that it will drive a proactive approach by the companies to avoid driver of the flow fails. So it's clear what the driver of the flow limit means. So it allows the companies to better plan, to reliant on agreeing with the agency appropriate steps if exceedances, to avoid exceedances becoming failures. So to do this though, it involves a new condition, and that has to be included in around 3,000 permits. So they all need variant, but we've got the opportunity to do that with because of the permitting of the AMP7 flow outputs, which we'll come on to shortly. So just quickly, the example I've got here, flow exceedance at Sewage Works on the 2026 data. Then if there were 2 exceedances in the preceding calendar years, 22, 23, 24 or 25, then it's a fail. So it makes driver the flow compliance equivalent to numeric quality compliance in terms of the ease of being able to say whether a discharge has passed or failed a limit. We'll also, including that driver the flow limit in permit conditions, we'll also be including some data quality conditions in the permit as well. Those data quality driver the flow monitoring data currently is in guidance, but it's going to be included in permit conditions to make the expectations clearer. So next slide, please. So why are we improving flow to full treatment? I'll move on now to flow to full treatment compliance, or flow pass forward flow compliance. So why are we improving it? Why do we want to improve it? So we want to make assessing flow to full treatment compliance routine rather than complex. So currently, checking flow to full treatment, it often requires use of data that's not been assessing FFT compliance, using monitors not installed for that purpose. And so it can be a very complex assessment to demonstrate beyond doubt that there's been a breach of flow pass forward, flow to full treatment conditions. So, and we know that there's increased scrutiny of storm discharges across the board from media, MPs, pressure groups. It's recognised that we need, as Oliver mentioned at the beginning, we need monitoring is needed to know what's spilling to storm tanks in the environment, and also to be able to check whether or not when the overflow operates, that it's whether or not it's compliant with its flow to full treatment and then other permit requirements. So having routine monitoring of flow-to-full treatment, it will give us a better understanding of the impacts, potential impacts downstream of sewage works, knowing better how they operate. So next slide, please. Thank you. So, AMP7 flow-to-full treatment compliance monitoring drivers. Yeah. So I'll just quickly run through these. So what the in AMP7, which runs from 2020 to 2025, there's some drivers for installing monitoring that will be used specifically to check flow-to-full treatment compliance. So that's at wastewater treatment works and also for what line those means there. So this is where the flow that controls from the catchment what goes forward for treatment is at a last in line overflow, which would typically be at a terminal sewage pumping station. So UMON 3 is event. Currently, there'll be probably event duration monitors on discharges from the storm tanks, but UMON 3 for AMP7 for flow-to-full treatment is to also on what goes into the storm tanks. So in addition to what we're monitoring what goes into the storm tanks, we're also monitoring under UMON 4 and having an installation of flow-to-full treatment flow monitoring. So those monitors, the data from those, the flow monitors and the data from the event duration monitors will be used to check compliance with flow-to-full treatment settings. So the driver allows existing flow monitors that are MCERT certified for driver of the flow to be used for FFT monitoring, if it's possible, to save costs of installing new monitors. But if an existing monitor isn't good enough, then the requirement is to install a new front-end flow-to-full treatment monitor. There's also a driver to have investigations, UINV2. So that's where it wasn't clear whether the existing flow monitor would be able to be used for flow monitoring of FFT or not. So that driver allows investigations to go ahead and check whether or not the monitor can be used. If it can, then it will be used in AMP7. If it can't, then it will get a driver for a new monitor to be installed early in AMP7. Sorry, early AMP8. So next slide, please. So as I mentioned earlier, there's UMON 3, UMON 4 permitting. There's getting on for 2.5, well, nearer 3,000. There's several thousand actual AMP outputs in all for UMON 3, UMON 4, but they relate to getting on for 3,000 sewage works and last in line overflows that will all require permit variations. So we've produced a new permit template which includes AMP7 flow conditions, and it's up to the agency's national permitting services and the water companies to agree permitting plans so that these AMP7 outputs can be permitted using the template, so that as well as the installations being installed and in place and being used, there are permit conditions that require them and set sort of parameters in terms of what has to be reported. So just quickly, this slide here is just, you often hear people talk about FFT, FTFT, and then flow pass forward. The permits, we all use the term flow-to-full treatment, FFT, but actually in storm permits, what's referred to is the flow pass forward flow. So I might use these interchangeably, FFT, flow pass forward flow, but they're essentially meaning the same thing, because flow pass forward flow is what we're talking about here, is the rate of flow that's arriving at a sewage works from the upstream collecting system that it served, that's passed forward for treatment, through the works. So UMON 4 and UMON 3 and MCerts. So MCerts, I think we'll probably hear more about MCerts over today and other days, but it's a certification scheme for monitoring, and there's one for flow monitoring. I mentioned it earlier for dry weather flow monitors. This relates here to the UMON4 monitors, which are measuring the flow pass forward flow. There will be a specific MCert certification for that purpose. And so all of the UMON4 monitors will have to have MCert certification during this AMP7 period. UMON3 monitors, they're the overflow operation monitors. There isn't a standard for that yet, but a standard is being developed. And so the intention is that those monitors that are installed in AMP7 will be MCert certified in AMP8. That's the plan. And the reason that we have MCert certification and why it's important is that data that's used for checking compliance, that's what the MCert certification scheme is there for. So it's to ensure that that monitors are properly installed with right equipment, and that they're managed, operated, and maintained under an MCert certified management system. I just would add as well that when I'm talking about UMON3, that's the EDM on the overflow operation monitoring of what goes over into the storm tanks. That MCert standard will apply only to it's there to apply only to those overflows, not all of the EDM overflows that exist across networks and on the discharges from the storm tanks, etc. Just clarify that point. So UMON4 MCert certification. So it's up to MCerts inspectors. They will come along to look at the installation, and they're there to confirm whether or not the flow monitor can be certified to monitor flow pass forward flow. So MCert certification for flow pass forward flow, even if it's the same flow monitor, it will be in addition to dry weather flow MCert certification. And so the inspectors need to look at the installation and flows that are arriving at the works, or you need to consider return flows, return process flows, because they may come in. There may be some process flows that come in upstream of the overflow, upstream of the monitor, and they all need to be taken into account. So there may be the need for subtractions. There may be need for monitoring of the flows to be subtracted. Or it may be that those flows can be just subtracted because they're now fixed. Other factors to take into account, there may be auto-inhibits that mean that actually these flows won't take place when the overflows operate, so they don't need to be included or subtracted. So there's also other complexities, considerations to take into account, like the site drainage from the sewage works, storm tank returns, imported effluent. So it's quite a lot of things to consider, and there might also be, in terms of back-end flow monitors, other aspects that need to be taken into account, because it may be that a back-end meter can be used at a works, or it may be that there's a lot of other added complexities that need to be taken into account, leading to higher sort of uncertainties on top of the flow monitoring uncertainties. But essentially, the MCerts requires that the flow monitor is able to measure flow pass forward, the FFT, with an uncertainty no greater than plus or minus 8% of that flow. Next slide, please. So the UMON2 investigation drivers. So there are quite a lot of sites where the operator wasn't sure that an existing monitor could be used, but the intention is that where possible, there'll be a prioritisation of the use of front-end monitors, front-end flow monitors, because they will better be able to measure and represent what's being passed forward for treatment, rather than one that's at the back end of the works. Back end of the works flow monitors might be MCert certified for dry weather flow monitoring. and perfectly good for that, but not necessarily acceptable or usable for measuring the flow that's being passed forward at the front end of the works. So if if that investigation, if it shows that the front end monitor can be used, then it must be MCERT certified and used to measure FFT within the AMP7 period. But if there's no existing front flow monitor that can be used, but an existing back end one can, again, that must be MCERT certified to measure flow to full treatment within AMP7. But as I said earlier, where there's no flow monitor that can be used, then that will result in an early UMON 4 AMP8 front end monitor that would be MCERT certified to monitor flow to full treatment. That would be as early as possible within the AMP8 period. So yeah, after 2020. So that's where yeah, more work's needed to install a new front end monitor. Next slide, please. So we're putting all these monitors in, or the companies are putting all these monitors in, getting them MCERT certified, and what will happen? What's the reason for doing that? So permits that how do we assess compliance with flow to full treatment and data quality? So currently, we control flow to full treatment with a setting condition in permits, and that setting condition will specify the flow pass forward that has to be met before the overflow can operate due to rainfall or snowmelt. So that condition is going to stay in the permits, but there'll also be a flow to full treatment limit that's been developed, and that will use a routine annual assessment to assess compliance using the UMON 4 MCERT FFT flow monitor data, the 15-minute flow data, and the UMON 3 overflow operation monitor, which will monitor and tell you when the overflow is operating. So that might be 2-minutely monitoring, polling every 2 minutes to say whether it's spilling or not, or it might be monitors that say, I started spilling at this time and I've stopped spilling at that time. So that data will be pulled together, and we'll look at that in a moment. But also, there'll be data quality conditions for UMON 3 overflow operation and the FFT flow monitors. And the intention is that there will be an annual compliance report that will be submitted by the companies to that will show compliance against what we'll come on to in a moment. So the FFT flow pass forward, so the limit, the intention of this is to make, as mentioned earlier with driver the flow, to make the compliance assessment more straightforward, so and result in a pass-fail result. So at the moment, if you're looking at compliance with the setting, it can involve fairly complex assessment of existing data, but moving forward, the intention is to have a limit, and then if this limit is failed, then we can be confident that the FFT, that it has failed, that the limit's been breached, and that it's failed, just as we will be with the new driver the flow condition or numeric discharge quality limits. So we'll use the UMON 3 overflow operation monitoring will show the periods that the overflow is operating, and then you'll take that 15-minute flow data whilst the overflow is operating to assess compliance, and it will involve some just to allow time for the flow to rise at the monitor. The first 15-minute flow readings won't be used, and if it's a back-end flow meter, the first two 15-minute flow readings won't be used. We can also agree there will be means of some readings being removed if there's no overflow from the storm tank and they're emptied as soon as possible where the storm tanks have been used for like planned maintenance purposes. So next slide, please. So the limit will look like, so if 95% of these 15-minute flow readings that have been taken whilst the overflow is operating must be at or above 92% of the FFT. So the limit is allowing for the uncertainty of measurement, data quality, time for flows, passing the monitor to respond to the increase in flows from the overflow control at the front end of the work. So if the limit's breached, if there's less than 95% of these readings that are at or above 92% of the FFT, we can be confident that it's failed, that the limit's failed, that the FFT required FFT is not being passed forward when the overflow is operating. So that's how it will work. The FFT setting condition that I mentioned earlier, that will remain in permits, along with the requirement that the overflow must only operate due to rainfall or snowmelt. So this last point here, that yes, there's this requirement that 95% of the 15-minute flow reading must be at or above 92% of the FFT, but that's not to say that you can just operate the overflow and set it at 93% of FFT and think, yeah, there I am, I've complied, because the setting condition remains, and the expectation is that that the uncertainty that you have is plus or minus either side of the FFT, not systemically below 100% of the FFT. So next slide, please. So this is if the overflow operates in short bursts, well, we're using 15-minute flow data based on the periods where the overflow is operating and discounting the first reading. So yeah, if you've got if you've got overflows that operate for like more than 15 minutes, going and extending onwards, you'll have 15-minute flow readings that will go into the compliance assessment. But if you've got if it turns out that the way your overflow operates, for example, if it's a pump storm overflow, it might operate on and off such that you don't get long enough periods of operation to get the 15-minute enough 15-minute flow readings to assess compliance. So we've said there that that the UMON4 flow FFT flow monitoring should be 2 minutes, every 2 minutes, and we're going to assess down the line whether or not there's a need to move to 2-minute flow monitoring in AMP8 if needed. Next slide, please. And this is just a rough example of the lines represent from the left there the period when the overflow starts to operate, and then each line is actually a 15-minute reading of flow data as the overflow continues. Some of those you can see go on for longer than 6 hours. And so what this is showing that depending on the conditions before an overflow starts to operate, the flow that the monitor's reading it can be relatively low if you're getting storm from a following dry period, or it can already be quite high if it's already been wet for a period beforehand. But what you can see there is a sort of dogleg at the front that's taking time for this flow monitor, for the flow passing the flow monitor to sort of be the flow that was passed forward by the overflow that's controlling flows into the works. And so that's why we knock off the first 15-minute readings in the assessment, or 30-minute readings if it's back end. Here it looks like it's taking around 30 minutes for some of these flows to sort of reach the overflow operation level. So then going across there, you can see that that the flows are sort of either side of 100% of the FFT, and you can see also that there's down at the bottom there at 40 or 45%. There's a line that potentially could be a discharge to the storm tank because of maintenance, and it might be that and assuming that the overflow didn't result in a spill from the storm tank and the storm tank was emptied, and those readings might be discounted from that 95%. The readings must be at or above 92% of the FFT assessment. So I don't, some of those blips there, potentially data errors, something's not quite right there. But that's just an example of what data might look like if plotted in that fashion. Data quality conditions, as I said, we're putting in the conditions in the permit that specify that you shouldn't have more than 14 consecutive days in the calendar year where you haven't got good flow data or good overflow operation data, and then 37 days in total where you haven't got both of those good data, both overflow operation and flow monitoring, effective flow monitoring data. So those quality conditions will be actually in the permit. Next one, please. And so at the end of the year, there'll be an annual summary report submission by the operator for each of these sites. So it will give you the percent of flow readings that were at or above 92% of the FFT whilst the overflow was operating. So if it's 95% or more, that's a pass. If it's less than 95, it's a fail. The max consecutive days, not good flow data, not good overflow operation data. If that's more than 14 consecutive days in either of those cases, then that's a fail of that data quality condition. Similarly, the number of days with not good flow and good overflow, if that's more than 37, again, that's a fail of the quality condition. So other things like for indicative purposes to understand what's happening and check there's no other issues, we also have duration of overflow operation, frequency of overflow operation, and then other stats such as annual mean, median flow, whilst the overflow of the readings whilst the overflow is operating, to be clear that yes, the flow monitoring is showing that the setting condition is actually being met, as well as the FFT limit. So the data is to be submitted to the agency annually by the operators, just as the driver the flow data is at the moment. So just the last slide, please. So yeah, the benefits of improving regulation. So it moves the regulatory focus to flow and effluent load, not just discharge quality. It makes driver the flow and FFT compliance assessment more straightforward and simpler, more straightforward and routine, and it sort of matches with the sort of zeitgeist at the moment and ongoing of the increased challenge and public awareness of the impact of storm discharges, and in terms of driving the flow, and well, the companies will need to plan ahead to avoid driving the flow fails and also ensure that there aren't FFT fails as well. So that bring a bright light to shine on the actual flow-to-full treatment compliance and driving the spills and sewage work. So that's the sort of from the agency's perspective of the benefits of improving regulation. So that's a whistle-stop tour through flow regulation and where we're going over the coming years.
So thank you very much, Pete. I don't know if I'm live.
Yeah, I can hear you.
Good. Thank you very much, Pete. Good. That's a great introduction to what is going on with flow. I know dry weather flow, about 2010, I think, had this sort of big update. I think we're now moving to FFT. I mean, Do you think, to be fair, do you think FFT's really been properly understood within the industry? I certainly know when I was a design engineer, FFT was treated as a maximum, which isn't the case. It's a minimum of a works must treat. Do you think there's part of the problem is that misconception that we've had over the years?
Yeah, potentially. I mean, it's like I said at the end there that we're shining a light on FFT. I mean, it's we as an organizer we focused on data, discharge quality. So yes, it's harder for us and the operators to sort of like routinely understand FFT. So yes, if it's not been in the operator's face or our face as to whether or not a sewage works is passing forward the right flow. So it's if companies may sort of because they're not having it in their face, might have sort of ignored the issue and assumed that things were okay when they might not be.
Yeah, from my point of view, it's always the message. I've worked for a few water companies now, directly and a few indirectly. The message has always been compliance is king, and that's meant quality compliance. And I think in some ways, flow management, especially with all the other issues at the minute, flow management is becoming more and more important. Quick question from Mark Swain. Half a question, half an observation. In 2019, we had a significant amount of rainfall. In 2020 and part 2021, many sites, especially the rural sites, treatment works, have seen increased flows as basic due to COVID and more people staying at home. What the question there is, what's a normal year for DWF these days?
Well, a good point. I mean, but if DWF does change, then yeah, it would have to change, wouldn't it? I guess ultimately, if flows are increasing at works, because genuinely there has been a change in that there are more people, there's more load actually going to the works now. It would have to, that would have to be reflected ultimately. We don't know how things are going to stabilise, do we? And I mean, the new condition, yes, it moves away from assessing on an annual basis whether or not appropriate steps are being taken, but it does allow there to be two exceedances that might be due to things that you're not, that are outside the control of the operator. So it's not in the operator's interest to think, I've got two exceedancies that I can wait for them and then do something about it, because those exceedancies, like you say, might be due to they're there for unexpected events.
Yeah, and to be honest, I mean, there's always the safety factor that was built into DWF between the Q80 and the Q90. Which has always been there. So there is a safety factor there, but it's well worth. To be honest, I think from my point of view, the 3 and 5 approach and the Q80 Q90 it works quite well. And I think that's a good part of it. And I think bringing forward flow management as a bring its importance forward is very, very important right now, especially with everything that's going on. On that note, I think it's probably worth bringing in Kathy Bora of Thames Water, who's going to look at FFT compliance in terms of a water company. I think probably the difficulties that we face, but I'll let Kathy talk about that. Kathy, do you want to take over?
Yeah. Hi there, everyone. So yes, as Oliver said, my name is Kathy Bora. I am from Thames Water, so I work within the kind of engineering and asset function, mainly in the environmental compliance space. So I'm the flow and EDM lead for Thames Water. As Oliver said, I think I've definitely seen my role expand from just a flow quality specialist keeping the MCerts program ticking over to now as the focus and attention is on flow, and we've realized just how important it is to get things right, to absolutely how my responsibilities expanded. We've now got a whole team involved, and it's really looking like this is something that we really want to focus and want to make our priority. So if we just move to the next slide, please. Just a quick overview about Thames Water. So Thames Water, we sit serving kind of London and the Thames Valley area. We've got kind of 15 million or so customers that we serve. So a very broad scope and a lot of customers to serve and to process, and we're going from teeny tiny little sewage treatment works in the middle of nowhere, serving a very low population, right the way up to kind of Beckton, one of our London sites that has a population of 2.5 million or so. So we really do see that kind of both broad ends of the spectrum in terms of the challenges that we're facing and what we're looking at. So if we just move to the next slide. Yep. So as kind of, I'm sure a lot of people are aware, the fact that you've come along to this session is just the interest in flow management and flow to treatment and storm discharges just has absolutely exploded over the last kind of 6 months to a year. We are seeing so much more media focus on it. We are seeing, we've had the Panorama, Panorama documentaries, we've had other documentaries, all really high quality media focus on it. Some really passionate stakeholders. I can't speak for all areas, but certainly in Thames Valley, we've got some really interested stakeholder groups that are from our Anglian Trust, from the angling point of view, from sailing, from open water swimming, because that has exploded over COVID. We're seeing paddleboarders, we're seeing everyone just being really interested in their local environment, in their local rivers, and they are quite rightly quite upset with what they perceive to be a decline in quality, in an impact on their watercourses, and they want to understand why. And they are challenging us as a water company, do better. What are you doing about it? We're seeing this impact. Is it from you? What are you going to do to stop it? And that's what we're seeing, a lot of interest from our stakeholders, a lot of interest from the media. We've had the Environment Bill, that's gone all the way up. Usually these things take a long time, and I think all of that attention and that passion from our stakeholder groups has really seen that in that addition to the Environment Bill of, specifically about water quality and things like that going into that. And I think actually we've got, the Environmental Audit Committee is sitting today listening to evidence from CEOs from water companies, including Thames Water. And I think it really just goes to show how interested everyone is in this subject and what we as water companies are doing about it. So if we go to the next slide, I can flash up what we are doing about it. Thames Water's position certainly is that, environmental harm, environmental damage is completely unacceptable. We don't want to be doing that. But first of all, I think we need to take a step back and understand, what is it that we're doing? What is our impact? What is happening in our environment? And do we have a part to play in that? So we've got various monitoring investment schemes that we've already been doing over the course of last AMP and this AMP, the kind of asset management period. So Pete covered some of these drivers, some of these focuses in his presentation very well. So on the left, kind of in the blue, we've got the kind of the monitoring schemes, and then on the right we've kind of got the what we're doing about it schemes. And as you can see, it's very heavily focused at the moment on just getting that monitoring in place, understanding what are we doing, how often are we doing it, where are we doing it, so we can try and really understand what is actually going on. So we've moved from, as Pete said, we've pretty much had various monitors in, but from a regulatory point of view, we've pretty much just had the dry weather flow, the final effluent. What are we finally treating and discharging into our watercourses. And now over last AMP and this AMP, we're really wanting to understand, okay, not just what are we discharging from a final effluent point of view, but what are we discharging from a storm effluent point of view. So there's various drivers with that. EDM1, EDM2 from last AMP, so we put those in to try and monitor what are we actually discharging from our storm overflows into the environment. And we're getting some really good data back from those now, really starting to understand where the problem hotspots are, what are we doing, how often are we doing it. Flow 3 and Flow 4, those are flow drivers, so those were to install more flow monitoring in various places. So Flow 4 in particular was a kind of prelude to what we're seeing this AMP, so it was targeting certain areas and trying to put some flow to treatment, flow monitoring in those areas. And then moving on to this AMP in investment, we've got the UMON 3, UMON 4 and UINV 2 drivers, which, as Pete said, the UMON 3 driver is to put monitors on not just our overflows to the environment, but actually the overflow to our storm storage on our sites. And that very much works in conjunction with the UMON 4 or UINV 2 drivers, which is to understand actually flow monitoring at the point of overflow. You know, what are we treating incoming from the network new? Are we meeting our obligations there? And I'll go into a little more detail later on about why that's so important to have those different monitoring points. And then again, on the right, as I say, in terms of regulatory drivers, we've got the UINV driver, which is our SOAF program, our Storm Overflow Assessment Framework. That's identifying using data from our EDM1 and EDM2s that went in last AMP, understanding where are we spilling to an unacceptable high amount. What, you know, are we investigating that? Are we understanding the reasons why? Cost benefit analysis, what can we do to try and reduce those spills? And the outcomes of those investigations will feed very much into our AMP8 investment program, you know, and get delivered there. Although obviously if there are any easy wins, we will be implementing them as soon as possible. We don't want to be waiting around. And then UINV 5 and UINV 6 drivers are all about, you know, can we increase, can we put more investment into our sewage treatment works to, you know, we might be meeting our flow to treatment value, for example, but actually is that flow to treatment value appropriate now? Have we had more growth in the area? Do we need to increase what we are treating as a flow to treatment value before we then subsequently discharge to storm? And then the UINV 6 driver is all about increasing the size of storm tanks on our sites. So it's understanding, okay, if we are discharging, if we are taking too much flow into our works, we're discharging to our storm tanks. Let's make those storm tanks bigger so that we've then got the opportunity, okay, can we then, if we're capturing more in our storm tanks, we're not having to discharge as much into the environment. Potentially we've got the ability there to store it in our storm tanks and then return it back to our works, you know, once that storm event has passed. So then we're treating more and we're not discharging as much partially treated sewage into the environment there. So as well as the regulatory drivers, we have also got our the non-regulatory stuff that we're doing. We're not just doing the stuff that's on the WINEP, on the National Environment Programme. We're, you know, I think Tideway Tunnel from a Thames Water point of view, that's probably our biggest investment, or probably our biggest known about investment. I won't talk about that as much now because we're talking about flow to treatment, and that's more focusing on the kind of the network sites in the London area. But we're also doing a lot of other investment in terms of identifying where are we non-compliant with flow to treatment. What can we do about it? We're engaging with the Environment Agency, with our local EA offices to understand, you know, where are we falling down? What can we do? Are there some quick wins in terms of, okay, it's just a matter of putting in some more, you know, flow regulation and a penstock tweak or something like that, right up into, okay, this needs a much bigger investment, and let's get some money together and get a program together to make those changes and make those fixes. So we are doing a lot now to understand what our impact is on the environment and to try and reduce that as much as possible within this AMP. Within the next 3 to 4 years. So we go to the next slide, please. all of those monitoring schemes, you can see what by the end of this AMP might be possible monitoring on a sewage treatment works, and I'll focus on sewage treatment works because we're looking at flow to treatment here. So as you can see, we've kind of got the inlet, we've got the final effluent, and then we've got a storm tank on a potential sewage treatment works. So by the end of this AMP, we might have via the UMON 4 driver a flow to treatment flow meter that is MCERT certified, that is, you know, calibrated, that is assessed independently, that has a management system in terms of maintenance and data integrity and data quality. We will have a final effluent flow meter that we've probably had for years and years and years, that again will be an MCERT certified meter, so we'll have its own management system and independent certification and everything like that. We will have the EDM to the environment, which we've already installed in most cases. So that will be not MCERT certified, but certainly we want to make sure we have the most accurate data we can. So possibly a little bit masochistically, we are implementing a management system in terms of maintenance and data integrity and data quality, because we want to make sure that we're reporting accurate data. And then via the UMON 3 driver, we will have the spill to storm monitor, which, although again won't need MCERT certification until AMP 8, again we want to make sure that we are measuring accurately and have full confidence in our data. So you can see on an average sewage treatment works, we might have 4 points, 4 streams of data coming in. As I'm sure many people on this call know, it's not as simple as what goes in, 1 point in, 1 point out. So in some cases, you might have multiple flow meters making up the flow to treatment flow meter flow data, and multiple flow meters making up the final effluent flow data. So that is a lot of data to keep track of, to make sure is accurate, to be monitoring, to be maintaining. This is, you know, I'm sitting here as a water company and we're realizing just how much this is going to explode. It's not just sticking the monitors in. That doesn't work. If you stick a monitor in and ignore it, you're going to get rubbish data. So you need to be looking at it. You need to be looking at the data, understanding what it's doing. You need to be making sure that there's maintenance going on. You know, we're seeing instances of where we're investigating spills to the environment, in inverted commas, and, you know, we get there, we've got a completely bone dry storm tank, and then you look and it's got a load of cobwebs under it, and you know, everything like that, and that's what's causing the spills, or you've got vegetation waving under it. So then you've got, you know, you realize, okay, actually the monthly check that we put in originally does not work at this site. This needs a lot of attention, and especially when you think, you know, summer months you get more vegetation growth and things like that. So having accurate data is step one for us. We can't do millions, billions of pounds worth of investment until we are happy and confident with the data we've got. So we move on to the next slide, please. You can see some of the things we're doing to try and make sure that we do have as accurate data as possible and understand what we're doing. So here we've got a dashboard, and it is showing us for a site what the rainfall's doing in the area, and that's taken from open source Environment Agency rain gauges. We've got in the middle, we've got what our EDM is saying, so that's our EDM to the environment. So that is essentially just level data. And then when the yellow gets over the red line, that is showing that that's a spill. That's, you know, overspilling the weir threshold. And then on the bottom, we have flow data coming from our final effluent, MCERT's flow meter, just to give an idea of what we're doing. And for all of the regulators kind of peering at this, don't worry, I've carefully selected a site that is squeaky clean and fully compliant. So I'm not... So yes, and I think as we were looking at this, originally we created this dashboard with a thought to just EDMs and verifying and validating EDMs. And so our thought was, well, we'll bring in some flow data and we'll bring in the rainfall data, because then we know, well, okay, if we're getting some data from the EDM and it says it's had a discharge and it's happened while it's raining and the flow's gone up, well, that's probably an indication that that spill was genuine, that was accurate. But of course, we then started thinking, well, actually, now we can have a really good indication of, are we compliant, as well as is the monitor working. So now we're looking at things and we're implementing and we're going, okay, can we, on a monthly basis, let's take the top 10 spillers in each of our operational areas, and we are now doing an eyeball check, and we're looking at not just are we happy those spills are genuine, but we're also looking and giving a kind of an indication of, okay, well, did that spill also happen when there was rainfall in the area, and did that spill also happen when our flow was reaching its flow to treatment level? And those are the sorts of checks we can already do with the data we have. There are some caveats with that. Obviously, this is a very manual process. It's kind of eyeballing it. It's relying on individual judgment, although my team are fantastic. I do trust their judgment, but it's not very helpful in terms of understanding, okay, as a whole, across our entire estate, what's our risk? What are our sites doing? So if we move to the next slide, please. We have also implemented some assessments based on the methodology that UCWIR came up with a few years ago. This was kind of trying to get an understanding of, okay, what is the kind of uncertainty due to flow, using final effluent flow meters and on that spill to the environment, because that's not necessarily what your flow to treatment's doing. If you've got a flow meter on a back end of a works and it's after a reed bed, after some filter beds, after sand filters in some cases, that is going to really stretch out your data, and what is saying at the back end isn't necessarily going to be very representative of what's happening at the front end. So can we do some statistical analysis to try and kind of smooth out those uncertainties, try and get the best idea we can? The idea is, okay, if you have a spill that goes on long enough, flow will kind of plateau through the works, etc., etc. So this is what we kind of tried to do, and in some cases worked really well. Again, this is a squeaky clean compliant works. This statistical analysis, if you look at this and try and think of it as this is the profile of an average spill from this works. So as you go along the graph, that's kind of the longer a spill goes on average. The purple, as you can see, that is every data point we have from an EDM, every spill data point we have. So as you can see, we have much more spills from this site that are the shorter length spills, and as the length of the spill goes on, towards the end, you've got like one spill that's gone on for 8,000 minutes or whatever it is. So then you've got lots of statistical stuff going on, working out what the 25th percentile is, what the 50th percentile is, what the 75th percentile is of all of the flow that's going through the works while the overflow is operating. So that's various things there. And then you've got a line which is what is your flow to treatment value. That's 100% of your flow to treatment. And we want to see, as you can see, all of those lines, all of that flow on average is above our flow to treatment figure. Beautiful, brilliant, compliant site. In fact, this site is so compliant, it actually has a driver to increase its flow to treatment. And if we move to the next slide, please, you can see where this methodology falls down a little bit with us and with some of our sites. Because now what you're seeing is you could look at that assessment and kind of go, well, okay, what's happening here is that flow at the start of a spill is not meeting its flow to treatment, and it's getting to the flow to treatment towards the middle and end of the spill, but that site is delaying, it's spilling early, it's taking 100 minutes to get to its flow to treatment value on average. But then you need to think, well, actually, where's this data coming from? If it is from a back-end flow meter, what is the setup of the flow on that site? Where is that? What's happening? What else is happening? What other returns are going on in order to impact that flow data? So in some cases, it's very, very easy. What goes in pretty much is what comes out, and you can match that up very, very nicely, and there's a very short delay. But are we confident what's going on? So this now is like, okay, it's not as simple now. It is now we need to figure out, right, is that just the delay of what's coming through the works? Is that actually, no, this site has a genuine problem and it is spilling early? And from our point of view, we're potentially going to be spending millions of pounds at this site's worth of investment if we think it has a problem that needs to be fixed. So this is a site where we'd look at and go, okay, actually, before we can make an 100% pronouncement of what the flow to treatment compliance at this site is, I think to be comfortable, we need a flow meter actually on the front end at that point of storm separation, at the flow at the flow to treatment, that is MCerted, that is, you know, as is accredited, is calibrated, is of a certain quality that we are confident in, before we to understand exactly what we're doing and exactly what the issue is. So this is a site where we really do need that flow to treatment MCerts meter, and it does benefit from that, and it shows why it is so important to not just have that final effluent flow meter sometimes, but also you need that UMON4 driver, you need that flow to treatment flow meter as well. And that's why often when I am asked, Kathy, what's your flow to treatment compliance across your estate, I do this sometimes, and I am very uncomfortable with giving a figure, and that's not because I don't want to be open and honest. That is because I am facing however many sites like this. We've got some really easy ones that I can make that and I can be confident in what I'm saying, and then we've got sites like this where I'm like, well, it might be this, it might be that, you know, we're not sure. And that's what I'm seeing when I'm looking at the data, and that's why I'm so excited about the UMON3 and UMON4 drivers coming in, because that removes all of that uncertainty, because it is actually at that point of overflow, at that point the storm tanks start filling. You can't argue with that, of what's happening there. So we move on to the next slide, please. Just talking about some of the kind of challenges we've looked at. As I say, data accuracy is a constant thorn in my side. I have thousands of flow meters and EDMs, and I've got hundreds more coming in, thousands more coming in of the UMON3 and UMON4 monitors. That is a lot of meters, a lot of data streams. You know, as Pete said, we've got the new UMON3 spill to storm overflow monitors are going to be 2-minute data. So I've got 15-minute data here, 2-minute data here to reconcile. I've got, you know, flow meters over here, flow meters there, flow meters there, flow meters there. It's a lot to keep track of. And keeping that data accuracy going, making sure that the maintenance is being undertaken correctly, reactive maintenance, you know, on a sewage treatment works, it's difficult enough, and then you consider when you go out into the network and you've got to get traffic management and try and convince Transport for London that you need to shut down a major artery in London because we need to access a manhole for an EDM. It's all fun and games, but it really is a challenge, just maintaining just the data accuracy and that data integrity before we even start on anything else. It's so important. As I say, other challenges we're facing, I said about the you know, the passion of the stakeholder groups we're getting, you know, through the environmental information request process, you know, under the Freedom of Information Act, anyone can request any environmental data from us, and they do. We get a lot of requests for data from stakeholders, from customers, from regulators, from the Environment Agency. Everyone now knows we have this data and wants it so they can see for themselves what they're doing, which is great. I'm so happy. We do have a lot of really interested and passionate stakeholder groups that want to work with us, but it's a lot. It's a lot of requests, and a lot of what we're doing at the moment is really trying to understand how we can manage that and how we can make that process easier for everyone. Because I'm sure stakeholder groups don't want to have to email us every time they want a bit of data and then wait 30 days to get it back, and then it's wrong, and then it's, you know, it's all this back and forth. Other challenges we're facing, the evolving regulation. As Pete said, there's a lot of really exciting stuff going on at the moment in terms of understanding what we need to do and how we're going to do it and how we best capture that, and making sure that every water company is treated the same and is providing the same data. There is a lot going on in that space at the moment, at kind of all levels, and it's just trying to make sure that we keep on top of that, we understand that, and that we make sure we know what's going on. And that we can plan and budget for it as well. That's quite important. And then, you know, linking in with the data requests, it's the data infrastructure. It's just making sure we understand, you know, how much extra data we do have coming in, how do we manage that, how do we calculate compliance from that, how do we communicate that out. You know, we can look at some really fantastic monitors and meters, and they're all using the Internet of Things and MQTT brokers and everything like that. And then you try and match that into our SCADA system that's, however many decades old, that really isn't designed to be compatible. I think we have got ahead of ourselves slightly with some of our UMON 3 monitors, and we're having to use a completely different reporting system at the moment until we can get that integrated into our full systems. But it's good because it challenges us to be better, to improve, to constantly be looking at the best way of understanding this data and capturing this data. Opportunities we have, it's, as I say, it's such a greater knowledge and understanding of our assets. It's sites that, I think everyone's got sites where there's a problem, and then you have sites where you're like, oh, okay, actually that's an issue there. What is that issue doing? As I say, is the issue that it's not meeting flow to treatment entirely? Is it that it's taking a while to get there? Is it getting there but not holding it? And understanding that is really helping us understand and target our investment needs and what we can do to do the best thing possible in order to fix what needs fixing. As I say, driving technological innovation, it really is. We are moving from, my own personal understanding from, has gone from being very, very basic, and the data stream sits there, and please don't ask me any further about what it does, and it does something there, to really understanding, right, what is the difference between the 2G monitors we have out in the network and the Internet of Things and Bluetooth, and someone can just go up and do it without needing to even access the manhole, and it's brilliant. And we have been working with some really fantastic contractors and some fantastic equipment manufacturers as well to really work with us to understand actually what can we do to do the best thing possible, not just to meet the current regulatory need, but looking forward to that. For example, the AMP8 MCerts coming in, we don't want to put something in that we're going to need to rip out in 4 years. How can we work with everyone to make sure that we're future-proofing as much as possible? Working in partnership with stakeholders, I said a lot about our passionate stakeholder groups, and they really they're really protective of their local environment, and we are doing some fantastic things at the moment in terms of understanding that and the citizen science that we are getting. We can't get out all the time, but actually we've got people that are willing and able and are really, really intelligent people that can go out and can take some samples and can give them to us, and we can understand so much more about what's going on. It really has opened up that dialogue so much more, this data. And of course, really, really importantly, reducing and preventing environmental impact. I am an environmental scientist by heart. That is my passion. I don't want to see, tampons and toilet paper and things in our environment. I don't want to see that. I want to do better, and I really want to, the environment to be improved by this. And I think some of the things we're working on, I can really, really see that we are going to make an active difference and an active improvement to that local environment. And I'm so, so excited about that. And then last, real-time data. That is what everyone wants to see. That is what everyone wants to do. We are away from that. I refer to all of my concerns about data accuracy, and I do not want to be putting data up on a website saying we're spilling if it turns out it's a bit of vegetation that got caught under the sensor. But we are moving there slowly. We are looking into it, and that's going to really give some exciting stuff as well for us. So that is it from me. So thank you very much for listening. Hope that gives a bit of an overview, whistle-stop tour of some of the challenges we're facing and what we're doing about it.
Thank you very much, Kathy. That's absolutely fascinating. I must admit, by my own count, I think one of the challenges, if you bring in UMON 4, a final effluent flow meter, UMON 3, and a EDM out the storm tank, nationally you're talking around about 500 million pieces of data every year. And I think, and that's at 15-minute values. If we go to 2, then we're talking 3 or 4 billion pieces of data a year nationally. And I think this is where, in some ways, one of the mammoth tasks is that data management. And it's staggering the amount of data that we will be collecting from 4 instruments per treatment works. But I think as you've highlighted very strongly, I think the value of that data is huge. I know it's going to come up in our next session, but what are some of the challenges on sort of data management that you have?
I think for us, it is that understanding, and it's the data comparison, and it's understanding, okay, the new flow to treatment requirement, for example, it's as Pete was saying, it's that 95% of your data while the overflow is operating should be above 92% of FFT, and then it shouldn't be 92% of FFT, it should be 100% of FFT, and it's just making sure that you have all of that data in the right place. And it is a lot of processing power. I came into this quite naively a couple of years ago, and I was like, well, I've an Excel spreadsheet, put some formulas in there and job done. No, it fell over immediately. So it's understanding we've got so much data, so much processing needed. It's picking out there's bits of suspect data so that you're not making an assessment on something where you knew there was just a log sitting under the monitor for however long. It's understanding how much data we've got coming in, making sure we've got the right processing power, and that we are understanding it in the right way and interpreting it in the right way, because that's so important.
It is that data quality, as you said. I've been a champion of data quality for a number of years now, and having trawled through, I don't know how much 15-minute data is just going, well, that's a spurious caused by a telemetry blip, or that's caused by this or that, or that data cleansing is extreme. And when you're talking 500 million pieces of data nationally every year, that challenge alone is massive, absolutely massive. So, but I think what we can get from that is there's a huge amount of value in this data, but turning that into information, very, very difficult. And I absolutely loved the dashboard you had there. Really, really like that. So at that, I think we've come to the end of this first session. I've programmed in a 15-minute comfort break for everyone. So hopefully I will see you all in 15 minutes, where we will be talking about managing the data and that 500 million pieces of data a year. We're going to have George Hayward of Avaro, Ronnie Baines, and a colleague of his talking about managing the data, and Sam Green from Southern Water. So I will see you all in about 15 minutes. Thank you very much.